So now our build is complete. We can go to the same thing. We'll right click on our folder and we'll click Run as Nios 2 Hardware. And if we go over to our console window right now, we can see a hello from Nios 2. So let's go ahead and stop this program, and we'll modify it a bit to make our LEDs blink. First thing we want to do is to include our system.h file, which includes all the definitions of our SOPC builder. And we'll also include a function library, which is called Altera Avalon PIO regs.h. After our hello world, we'll declare an integer count. We'll also introduce our integer delay. Count should equal to 0. And we'll include a while loop. And so now we're going to call a function from our Altera Avalon PIO regs.h file, which will be IOWR, which stands for IO write, Altera Avalon PIO data. And here we'll include our addresses, PIO, LED base, and our value, which will be count with the AND operator, and 0x01, which is a hex value for 1. And we'll set our delay to 0 here. And to implement our delay, we'll have a loop where delay is less than 2 million. Delay plus plus. And count plus plus. Okay. Now we'll save this file. And we'll do the same thing. We'll build it again. So our build is complete. Before we run this project, it's important to note that the system.h file, which is included in our syslib over here, our automatic file, our automatically generated file, the system description is right here in debug, system description, and system.h. If we open this up, and we scroll down, we can see our system configuration for all of our components defined in SOPC Builder. And we go down, we can go to our input-output ports, and here we can see what we called earlier, our PIO LED base. And this is defined as the same address that was included in our SOPC Builder. Hence, the PIO LED base in our IOWR function. So now that our build is complete, we can run this project, run as Nios 2 Hardware. Now it's done downloading. If we look over to our D2115, we can see our green LED is blinking. If you want to know more about the functions that are in the Altera Avalon PIO regs.h, you can open that file. If you go to the Quartus folder, it should be under the following file path: There's four main functions in here. There's the read, write, IRQ mask, and edge cap, which is basically mapping to the registers. You can find out more about these IPs in the documentation of SOPC Builder and within these files. So now let's do our last step, which is to make our instruction set stored on our flash memory, so that when we turn off the DE2115 board, we'll still be able to run our Nios 2 operations. So let's go to Nios 2, and we'll stop our program. And now let's go back to our Quartus 2 and open up our SOPC Builder. So here we want to add a flash memory. Now, in order to do that, we want to be able to also add a tri-state bridge to communicate with the flash memory interface. The Avalon MM tri-state bridge will be included in Bridge and Adapters under Memory Mapped right here. And we double click that, and we click on Finish. And we can see our tri-state bridge is included. And let's rename this. Get rid of the _0. Now we can add our flash memory interface. The flash memory interface is included under Memories and Memory Controllers and under Flash. And we'll set our address bits, our address width to 23. And our timing for setup, we want 60 nanoseconds. Wait will be 160 nanoseconds, and hold will be 60 nanoseconds. We click on Finish. And now what we can do is link these two, the tri-state bridge to the CFI flash, by clicking on this blank dot. And by clicking on it, we can easily connect the two. We also want to rename this to CFI flash. And we'll double click on our tri-state bridge again and make it so that we have data as shared signal. We finish. And our last step is to set our reset vector to our CFI flash for our CPU. Click on Finish. We will go back and auto-assign base addresses again. And now we can click on Generate. Save. So now that our system generation is successful, let's exit. And over here we can see that our generated file is different. Let's go ahead and find it again. SOPC. Click on Find Next. And as we scroll down, we can see that in addition to our earlier components, we have the added components of our flash. So we'll copy this over to our top module again. We'll replace our earlier one. And we type this as module U0. Declare these again. So now we can reassign this, our clock 0, as clock 50 input. Reset as high bit as well. Our output port, LEDG. And for flash, we have to assign the corresponding addresses which were declared by our system builder. So our address, which was 23 bits, put here. For read enable, this would correspond to our output enable. For select enable, this will correspond to our chip enable. Our tri-state bridge data, we will use the this variable. And for write enable, we will choose write enable. In addition to that, we will also want to set 2 bits to high, which would be the reset, which is active low. So we will type assign equals to 1. And we will also disable the write protect because it is active low. We will also assign that a 1. Now that we've written that, we can go and compile our new project. Now that our full compilation is successful, we'll go back into Nios, and over here we could see our syslib. We're going to have to change some variables in here, so we'll go to Properties, and we'll go down to System Library. And over here we can see our configuration for our memory and our JTAG. Over here we're just going to change our program memory to our flash, and our read-only data memory to our flash as well. Apply. We'll click OK. And then we will build our project again. So while this is building, we'll go back to our Quartus, and we'll also open our programmer, and we'll program our DE2 115 with the new program. So now that the build is complete, let's program our flash memory. So we go to Tools, Flash Programmer, and we'll click on this. And now all we have to do is to click on Program Flash. And a warning signal will come up asking us that the flash programmer cannot be canceled once programming starts. We click Yes. We're done programming the flash. So if you look over to the DE2115 board right now, what I'm going to do is I'm going to turn it off, and I'll turn it on again. And let's go over to our Quartus 2, and I will program our SOF back in. And if everything goes to plan, and the LED on the DE2115 will start blinking automatically without the use of the Nios 2 IDE. This concludes our tutorial on building your first Nios 2 and SOPC system. If you have any questions, please email them to support@thoracic.com.tw. Thank you for watching.